All right, so good afternoon and welcome to the August Smart Grid Educational Series webinar, which is also having a concurrent seminar here in Culver City, California at National Technical Systems. And Gary Sorkin and Osman Sakra and Raymond Chung, all of you, thank you very much for hosting this event here in Culver City. We are trying a new concept here. And I think, judging from the way the last hour went, it's very successful. We are getting people who are involved in this business to get to know each other by face and have informal discussions around an event whose main purpose is to educate. We are not trying to sell product here. We're trying to understand concepts, and then as a result of those discussions, one could approach companies and do good work. And so the people that are sitting here in the room, as well as those of you who are on the webinar, you will really benefit from knowing what the cutting edge technology is all about and what its implications are in the energy sector. So we are very, very privileged to have John Hayes today. He's the Chief Technology Officer of BlackRidge. He's also a co-founder?
Yes.
A co-founder of BlackRidge and an expert in cybersecurity and very knowledgeable on the communications end. So with that, what I'd like to do is welcome John, and we will then, after he is done with his presentation, go into a Q&A mode where we will entertain questions from the audience here in the room, as well as from you on the webinar. Now, for those of you who are on the webinar, if you're occasionally having sound problems and because the internet stops sending you an audio feed, go ahead and dial into the number that you have, the 650-479-3208, and put in the access code that you received when you registered for this webinar. And then you will be connected to the audio portion by telephone. And then when we get to the Q&A, then you can enter those questions in the Q&A section of the webinar GUI, or you could put it in the chat. And we will go through all of those questions one at a time. I'll read them, and then John can answer them. So with that, welcome, John.
Erfan, thank you very much for the introduction. I'm John Hayes, CTO of BlackRidge Technologies. And before we get started, just a brief comment. BlackRidge really specializes in identity and networking, and we're stretching a little bit as we move into industrial control systems, but we believe that there is really great applicability, and the concepts we're going to talk about really stretch almost to any network systems. But anyway, so just as we're going here, we're really going to be spending, I'd say, a bulk of the discussion around networking and security technologies with respect to identity. So let's get started. Everybody's seen the number of news reports in the popular press, in trade press. Cybersecurity really has become a mainstream topic over the last several years. The number of attacks, not just on networks overall, but on industrial control systems has jumped dramatically in the last couple of years. And there's pretty much, I would say, nothing is going to be spared. Everything that has digital assets will be attacked. More specifically, there are some very specific attacks highlighted. Okay, everybody's probably by now heard of Stuxnet. You've probably also heard of Flame. It looks like there's some derivatives of Stuxnet in the Flame attack. Both of those are various forms of attack on industrial control systems. Although those have been successful we believe that those have been successful, but we still don't know exactly who originated them and what they were trying to achieve. But based on what they've done, it looks like those were at least partially successful. Outside of pure attacks, people have heard of Shodan, which is basically a search engine for vulnerabilities for systems, SCADA systems, industrial control systems, and Project Basecamp, which was an analysis of a number of logic controllers and what sort of things they could do to them. All of these are fairly scary in terms of how open these things are. So what's driving all of this? So there's really three things that we're looking at as the drivers, okay? The first one is increased use of networks by industrial control systems. They're becoming more networked. We'll go into the reasons why in a minute. Networks have vulnerabilities. We'll talk about that. And then the other thing is it is becoming much more public, much more exposed. Not only are the attacks happening, but the attacks are being reported. People are seeing the effects, if not physically, they're at least seeing it in the media. So all of this comes together, and it shows up as increased attacks on these industrial control systems using network vulnerabilities. Okay, breaking it down, increased use of networks by industrial control systems. This isn't anything new. It's all driven by cost and efficiency. It really comes down to you need to have your employees access remote equipment. You need to have vendor technicians access remote equipment, and you want to do all of this stuff without rolling a truck. How can you automate the maintenance of equipment? How can you automate data collections? All of these things are the drivers, okay? And there's many more details. I don't have to go into the rest of the drivers, but everyone knows that there's all these drivers on why things are being networked. The other thing that's really interesting here is this is the first time things have been networked. Things have been networked for a long time, but now you're seeing migration from serial protocols and other protocols that used to be more or less private. When I ran my own serial lines, you had to have physical access to get to those lines. Once things are networked using, TCP/IP protocols, now I can get to them remotely. The big thing that this thing underscores is I'm essentially outsourcing all my connectivity to network protocols, and I have to trust those protocols. If I don't trust those protocols, or if those protocols do not deliver the trust that I expect, we are open to compromise. So just by moving to more network things, you got to be careful because you have to make sure that the networks are worthy of the trust that we're placing in them. Network vulnerabilities. I'm not going to go into every network vulnerability. I'm going to talk about two specific trends here. The first one, which I'm going to dive into in more detail, is implicit trust in the network. We trust the network. And more than that, at a technical detail, we are using implicit trust as opposed to explicit trust. The other thing is we've been focusing more and more on application layer security and application layer policy enforcement. Partially that's because of the trust in the network. Application layer policy enforcement is a good thing, but it occurs after you've already communicated with the device, after you've established sessions. Strengthening that application authentication and all the application security is absolutely necessary, but in and of itself, it is not sufficient. As people have been focusing the last several years with third-generation firewalls, people talk about application firewalls and things of this sort, lots of focus has been paid in this area. In some ways, less attention is being paid at the networking layers themselves, the layers that underlie the application layer, leaving them vulnerable to exploitation. Okay, I mentioned we're relying on implicit trust. So where did this thing come from? Way back when the internet was started, you had a couple of government agencies and a bunch of universities that wanted to have computers and tie them together so they could communicate. So they wired them up, and there was no security aspect to the protocols. You could actually wire the machines together. This is where you came up with, IP and NCP, it evolved to TCP, and the machines talked, and it worked very well from a pure communication standpoint. But as you started scaling up, everything from your local hackers in college to grad students started trying to mess around on machines they shouldn't. So, okay, there isn't anything to trust here, so I've got to do something. Okay, it worked to a certain level, but as you started to scale up, you had no trust. So what they do, they invented the firewall. The firewall worked very well, and what it did is it said, okay, I'm going to draw a line here, and everything on the inside of the firewall I'm going to trust, and everything on the outside of the firewall I'm not going to trust. Okay, that works, but why am I trusting stuff on inside the firewall? I'm trusting it, again, based on implicit trust. At the network layer, what information do I have? I primarily have addresses. IP addresses, whether they're IPv4 or IPv6, are not authenticatable. Why is authentication important with addresses? Well, if I can't authenticate it, I can fake it. I can spoof or pretend to be any address I want to be, and this causes, this makes trust in networks difficult. So they came up with VPNs. VPN takes the device on the outside, allows you the same access on the inside. I may use identity to establish the VPN tunnel, but once the data exits that VPN tunnel, I'm back to using implicit trust. Going forward, okay, we still have some challenges here. So let's use intrusion detection. Let's use, these application layer firewalls. Stuff works very well. The application layer firewalls actually begins to have explicit trust. But this explicit trust is communicated at the application layer, and that identities as part of the implicit trust at the explicit trust at the application layer is not accessible within the network. So you're building all of this stuff up, and here is where all of the application layer security starts to get involved. It's not just on the endpoints, it's at these various midpoints whenever you're establishing a security boundary. So we're still having a hard time trusting anything below the application layer. So application layer policy enforcement. It really does sound like a good thing, and it is. It's a very good thing. This is where we get our single sign-on. This is where we get to use our smart cards. This is where we get to use our RSA tokens. All of those are interpreted at the application layer. The reason they're interpreted at the application layer is things like a single sign-on or a smart card. I'm moving a PKI certificate back and forth as part of the identity. I sign it, but that certificate, it can be a K or more in length. It's big. It's very hard to take something that big and make it accessible down to the network layer where I might have far less data, especially if I'm trying to add it to every packet or every single session. So the other thing about application layer policy enforcement is anytime I use something from the application layer, that means the TCP session has already been established. The things that really drive application layer policy enforcement, number one is mobile devices. Mobile devices, first off, dynamic identities, they're moving around and they're accessing resources all over the place. The second thing that's driving this is cloud. Think of TCP. TCP is the access method for the cloud. You don't think of establishing a VPN to the cloud. That actually has its own scalability problems. So everyone establishes the TCP session, and then for security on top of that, which is link security, not identity, you'll establish an SSL or a TLS session on top of that. The other things that are driving application security is organizational complexity. Anybody who has worked in a large organization and has tried to deal with ACLs and map your network topology to your organizational topology knows how frustrating it is the next time the organization goes through a reorg, acquires something, or divests something, and now the network topology no longer matches your organizational topology, and you have a mismatch. What happens there is that somebody needs to access a resource that's supposed to be shared, or somebody needs private resources. The complexity gets too much, and something has to give, and almost always it is a security policy around the ACLs. Your network ends up flattened, and you do all of your policy enforcement at the application layer because the application layer is topology independent. So you end up with this flattening of your network layer. The worst example I've seen of that, not in an industrial control system, is I was at Citibank offices in New Jersey. The guy was able to reach out and touch a cash machine, an ATM, in Hong Kong. That's fairly interesting. So the other challenge with ACLs, assuming you can even achieve what you want, is just the constant coordination. With mobile addresses, with dynamic addressing, that becomes difficult. And finally, the whole simplicity from the user perspective of using it, and simplicity and ease of managing it from the administrator side. So these are all the things that are driving application policy enforcement. application policy enforcement is a good thing, but it's not the entire solution, because now you've left your network relatively unprotected. The challenge and the risk of doing everything at the application layer is, number one is port scanning. Okay? If I open my underlying network, I can now go out there, see what applications are there, see what hosts are there, fingerprint them, figure out what my attack vectors are. We already talked about I can't authenticate an address. That leads to rogue devices, and it leads to rogue applications. And the last one, of course, is data exfiltration. There's things that you have on your networks. It's your proprietary data. People want to steal it. Whether it's for exposure, whether it's to gain information, it doesn't matter. They still want to steal it. So today's network securities, very typically, you're going to have firewalls, you're going to have some form of intrusion protection or intrusion detection devices, and you're going to have VPNs. All of these are very good devices. They are part of the solution. They all have done a great job in limiting or mitigating attacks. But today, all of them together still don't solve the problem. So once again, back to why is all this stuff happening? Well, the number one reason it's happening is because more and more assets are digital, meaning these assets can be accessed via the network, and these assets have higher and higher value. Okay, so now there's something out there. So of course, what's the motive behind it? Usually financial gain, mayhem, threat of mayhem, and these can be done by either state actors, cyber warfare, or non-state aligned actors for various reasons. Interesting point about all of this stuff is the sophistication of the attack is related to the value of the target. Don't assume that just because you're using a protocol that nobody's seen before, they can't reverse engineer it. If you have something of high enough value, it's going to be attacked. You guys already know this, but it's basically, the more interesting stuff you have, the more likely that you're going to be attacked. The resources put into that attack really depends on the motivation and the value of what they're trying to get out of it. So, with all of this stuff, industrial control systems are only going to become more networked and more dependent on network connectivity. Attacks are going to continue through these networks. So if we can't basically say this trend isn't going away, the attacks aren't going away, our only solution is to figure out how to harden the networks. So far, we've just talked about various reasons why the approaches to date are necessary but still insufficient. So I'm going to take a couple slides and dig down a little bit more into the technology and explain a few things, and then I'll bring it back up and figure out how we can apply all this stuff. Everybody's heard of the 7-layer ISO protocol stack, as shown on the left-hand side here. The Internet more or less implemented five layers, 4 layers, depending on how you count it. Sometimes the physical and data link get merged together. But what's really interesting is thinking, what are actually the responsibilities of those layers? So the application is still the application. The transport layer is responsible for the end-to-end communication. This is where the session happens. It's the transport layer with TCP that's the access to the cloud. Layer 3, the IP layer, is responsible for routing. How do I get to the cloud? And everything below that, that's all local. When I say local, that is, am I using Ethernet or Wi-Fi to access the Internet? What is my local address? Because those, in many cases, from your office, from your home, from the coffee shop, the address you're given locally is translated to some other address. So that's just sort of the local stuff. So within those, I'm going to focus very briefly on IP and TCP. We already mentioned that addresses are not authenticatable. So why are addresses important? Addresses are how you identify an endpoint. If I don't have an address, I can't talk on a TCP IP network. So if I'm on the Internet, I have to have an address somewhere. They're implicitly trusted. Implicit means I can't authenticate them. If I can't authenticate them, I can impersonate them. I can fake them. That's one of the big risks. The network layer, it delivers packets. It doesn't do sessions. The other thing about the network layer is the network layer delivers what we call best effort delivery. Delivery is not guaranteed. If I send a packet off, it may get there, it may not. And if the packet is dropped for congestion or for whatever reasons, there is no indication made to the sender. So I've got this network that knows all about the connectivity, but doesn't do anything for me to ensure that the data gets there. And of course, everything below the IP layer, that's all local. So how do we actually make this work? Well, that's what the TCP layer does. This is probably a review for everybody, but basically the TCP layer is responsible for in-order delivery of your data, retransmission if it doesn't get there, and it notifies the application when all of this stuff actually gets there. So the application knows the data has been delivered, the other end has received it. So to provide those features, TCP needs to establish a session. And the session really has 3 phases of operation. There's a session setup phase, there's a data transfer phase, and there's session termination. Now we're going to focus today mostly on session setup and data transfer. Session setup is, when they designed the TCP protocol, there was no provisions made to allow any form of user data, and that includes credentials for identity during session establishment. What that means is I go through session establishment phase blind, I move into data transfer, then I send over all my credentials. One way of thinking about that is how the phone system operated prior to caller ID. Phone used to ring, you pick it up, you say who's there. Well, whether you wanted to talk to the guy or not, he's got you on the line, he knows you're home, and anyway, and it's so much easier now. I mean, we all, okay, who's calling? Oh, I don't want to talk to that person, let it go to voicemail or just don't answer it, okay? That's what we'd like to have for the internet. Okay, how can you have identity before you establish the connection? Picking up the telephone is the establishment of that session. Okay. Another way to look at it, the same thing here. On the left, you have a client who is making a TCP request. On the right, you have a server. Could be your email server, could be a web server, anything that uses the protocol. What's shown in gold there is the session establishment portion of the TCP protocol. So I communicate, I send things back and forth, and I respond without performing any authentication. Then we move into data transfer in the blue, then I send over my credentials. So if John here is trying to connect, if John's playing the client and I'm playing the server, he establishes a connection. I've answered the phone, and he's already sent, this is John's credentials. And one of the interesting things about here is this is how network reconnaissance and port scanning works. There's no authentication. This is how I can go scan your network and tell you exactly what's on it. Apply some fingerprint technology to that, and now I know my attack surface. Okay, I will tie this all together, I promise. One more thing for background here. This is a very simplified industrial control system overview. At the bottom, you've got your sensors and actuators. Above that, you've got your logic controllers, you've got your management systems. Somewhere in there, you've got your all of your back office, the internet, and finally you have your remote technicians, whether your technicians or the equipment vendor's technicians needing to get in there. How do you provide them secured way of doing this that you can trust and everybody can trust? So I'm going to dive in here into a more detailed architecture. This actually comes from Siemens. I'm not trying to pick on Siemens here. The things I'm pointing out are not specific to Siemens. We believe that they apply to pretty much any industrial control system architecture. So although I'm using Siemens because they had a very nice picture, I'm not trying to talk about Siemens. There's 3 administrative layers in this diagram. At the top, you have the operations layers. So you have both the operation consoles, you have the remote access, all of that comes in there. Below that, you have the control layers, and beyond that, it's what they call the field, that Siemens calls the field level, that actually touches the sensors and actuators. So I'm going to talk about 3 different vulnerabilities here, and then let's figure out what we can do about them. Vulnerability A is really, they claim to use firewalls, which filter on addresses, and VPNs to establish the link between the operations layer and the control layer. That works very well, and VPNs do their job, especially, VPNs, you're not going to break a VPN generally. Okay, they work very well. But the data entering the identity and anything used to secure a VPN only lasts through that VPN tunnel. If it comes out the other side, I'm now back to implicit trust. I can have something at the operations layer pretending to be It can be malware, it can be a rogue device, and I can use that access of the VPN to securely communicate into the next layer down. This is how things propagate and cross boundaries. So a lot of it on how do you keep things out is based on ACLs and addresses, and we need to move from an implicit trust model to an explicit trust model. The second one is really more along the lines of configuration management, and how do you set things up properly. This quote actually comes from the Siemens documentation. So everything from diagnostics to how you set up your networks, all of that can be controlled. If that's not tightly controlled and properly set up, you can inadvertently leave your networks wide open. The scans conducted that are now on the Shodan system, which was the catalog of control system attack points, probably the vast majority of those came from improperly configured or insecurely configured networks. It's not that they didn't do things. They might have done things right, but they had left diagnostics on, they leave insecure protocols on, things of this sort. So this may be one of the biggest risks. This, make sure that, you know, if you don't trust everybody, and we're still relying on implicit trust here, you've got to get this this part right. It's not impossible to get right. It's just it requires work, it requires diligence, and it generally requires, you know, training of your field and people knowing how to do things right. But these things are not set up for ease of use and what we would call, you know, fail secure behavior. Okay, the defaults are not set that in such a way that that you're always going to make sure that you're secure. The last one, this one's actually pretty interesting. Once again, this is another quote from the Siemens manual. Can be activated. Personally, I think they should have that much stronger. First thing is, it's great that they actually have support for secure protocols. This basically involves establishing your TCP sessions and then running TLS on top of it to secure your data. That part's very good. Even though you do that, first thing you do is make sure you're not running anything that's using RC5 hashes. Those have been completely compromised. And even with that, they are still subject to man-in-the-middle attacks. This gets back to understand what is the value of what you're protecting and how much the attacker wants whatever it is you're protecting, and the time and money investment he's willing to invest to cause that. So even though you have secure protocols, they are not the answer to everything. They should absolutely be used as much as you possibly can. So I know these are sort of some broad-ranging risks, but let's talk about where we think we can change things. Okay. One last point here. We wanted to, you guys meaning the industry of industrial control systems, have already made a tremendous effort in networking, in investment in security, all of this stuff. The first thing we do is we don't want to have that investment go to waste. This is not a forklift upgrade. So one of the big requirements is how do you leverage all of your existing investments and then still move forward in a way that works? What we think, what I think, what BlackRidge thinks is you start off with, you use identity, you authenticate identity before responding, and then you implement identity policy based on trusted identity. You're already probably doing this at the application layer. We want to do this down within the network. Make the networks aware of identity, be able to authenticate that, and now apply your policies. Once you have identity, this gives you the ability to move from implicit trust to explicit trust. Several times in this presentation, I've mentioned how much of it is just you're basing it on implicit trust. You are implying that trust is there. Well, we want to make that explicit. So this is necessary to secure the networks now into the future. Explicit trust really requires identity. And when I say identity, this is strong identity. The best strong identity has got to be rooted in hardware. That can be everything from your smart cards to TPM devices in laptops, in industrial control systems. The technology already exists. And then as you do this, just like application layer identity is independent of topology, this solution also needs to be independent of topology. You want to get out of having to manage your access control list, and you want to get out of the practice of having to compromise your ACL policies to deal with access control. So we want to stop doing compromises. We want to stop compromising our policy. We want to make things topology independent from a networking perspective. So the requirements of the solutions like this, number one is secure. Number two is scalable. That's scalable with respect to bandwidth, scalable with respect to identity, and scalable with respect of management. How do I actually make it manageable? We just talked a little bit about backward compatibility. There's been a tremendous investment made. You've got to leverage all of that. It's got to protect the identity or the privacy of the identities. As we use identities on the network, we want to make sure that if there is somebody there snooping around, by monitoring the traffic, they don't gain additional information. So the privacy of the identities that are being used in these systems also needs to be protected. And lastly, it's got to be high performance. It can't impact the operations of what's already going on. So here's this picture we started off with earlier, talking about TCP. Instead of waiting until we get to the data transfer phase, what we do, and one approach is to insert identity starting with the very first packet. We can insert identity into a TCP Syn packet when it's received at a policy enforcement point, and this is something that can be done not just at the endpoint, it can be done at multiple points along the path. It's an end-to-end solution, so anywhere you want along the path, you can interrogate that identity and apply policy. That policy can be access control policies, it can be application routing policies, it can even be QoS policies. So what does that do to our model here? Well, we've taken identities, we've given them to the operators, we've given them to the embedded systems, and now we can actually identify what's going on every single time a TCP session. The TCP, we're not changing the applications here. There is no change to any of the applications, but every time an application establishes a TCP session, we are able to identify it and say, is this the right either device or user to establish this session? Do we allow it? What happens if we get a rogue device on here? If we get a rogue device that does not have an identity, then it will show up as anonymous, and now we have a policy for anonymous. In most cases here, it's just going to be block or deny. What that looks like to somebody who's doing network scanning is suddenly your network went dark. You can't see anything. Okay? We can take all these machines that are on the network, they're still on the network, but if I don't have the identity, or if I have an identity and I am not authorized, I don't see anything, even if I'm on the same LAN segment. So we call this identity-aware networking. And it's standards compliant with TCP. It's all standards-based. It does cloak or can make your systems invisible. We enable authentication at the network layer. And I'd say the big thing here is security and simplicity. Stop worrying about the topologies from an ACL point of view. Make it easy for your users to access the resources they need when they need it, and make it easier to administer. This really operates, so this is, just to summarize this, your ACLs, they're insecure because you can't authenticate addresses. So instead of trying to solve that problem, they're now redundant, they're not needed. You eliminate the coordination activity of ACLs. We now can authenticate on any TCP request, and your attack surfaces are greatly reduced because you've now blocked or reduced port scanning and network reconnaissance. Interestingly enough, port scanning and network reconnaissance is part of the security regimes of many organizations. We do not, if you want to run port scanning, you still can. All you need to do is make sure that the user or device has the proper authorization to do it. We're not saying we're shutting down all port scanning. We're saying we're shutting down the port scanning by unauthenticated or unauthorized users. So everybody's read various analyses of Flame and Stuxnet. We have too. We don't know that any of them are complete, and we don't know the original motives. We do believe that there's portions that we could have stopped or mitigated or blocked portions of that. That is supposition, but it's something that we think. Using identity-aware networking is applicable to all three of the various layers we talked about, the operations layer, the field layer, and the control layer. And the other thing that's really interesting is I spent this entire conversation talking about getting in, how do you get into things? Haven't talked anything about how do you get back out. What about command and control systems? What about data exfiltration? The same technology that using internally can also be used in an outward-facing way. I draw a boundary. I've got my identified things that are identified. The first thing I do is anything that I don't want to go past the boundary that doesn't need it, doesn't have an identity. Does my printer need an identity? Does my HVAC system need an identity? I may want to do it just for accounting purposes, but I'm not going to do it for an access purpose. Anyway, if I have a perimeter built, it allows me to say, if you have no identity, you don't go beyond the perimeter. After that, everything else, you want to specifically, what is your policy, either a group policy or an individual policy, are you allowed out? This allows you to take your various control systems. Some of them absolutely need to communicate, and they can. But the ones that shouldn't are now easily blocked, and it's not based on ACLs again. So in other words, if somebody wants to reconfigure the network, they can reconfigure the network without changing your security policy. So to wrap this all up, I think this is the last slide. The big goal here is eliminate and reduce risks in these control system architectures. We're going to continue to use networks. They're going to expand, leverage our deployed investments in both applications, security, and infrastructure, but harden them by making the networks identity aware. A lot of it really gets down to how do we make it simple to use, simple to administer, and as easy as possible to use, especially from the users. Everybody knows that the last thing you want is calls to the help desk. If you can do this stuff in a way that the user doesn't see the impact of it, so your networks are more secure and your users don't see the impacts, that's really what we're looking for. So that's it. Thanks.
Very good. So I think one of the things that came out of this presentation, which I thought really stood out, was that there's a paradigm shift from identifying people with IP addresses to identifying people independent of IP addresses so that they could move around within the organization. They could be coming from different parts of the world, but they have a unique, so that whole concept of single sign-on where it's no longer connected to a physical or an IP address. I think that has scalability, and it'll allow people to have their privileges removed or given to them. The other thing is that with that, you are no longer technology dependent because the type of authentication you can use can get more sophisticated with time because you're using this concept of universal thing. The other thing is that in terms of what this will do to TCP/IP networks and how we are going to think about roles of the different devices and how it will work when you have so many parties, especially in the electric sector, with all these parties that now have to collaborate with each other, that having this common currency for security authentication, I think will bode very well, so that NIST and other organizations that put minimum levels of security, for authentication could start saying that, if you are going to be in that mixed environment, you need to have something of this kind. Now, there could be, BlackRidge, you've started this idea, and I'm sure that there will be many variations of this over time, and you will have a market share. Other companies will come in and play in this space. But the main thing here is that we reached in the, I would say, performance and effort curve, kind of like the top of an S curve. with some 30 years. We were talking about this with the Internet Protocol over a 30-year period. And it's time to develop the next S-curve, if you may, in order to enable new applications that we are thinking about. But our physical infrastructure is not ready for that prime time yet until some of these additional bells and whistles are added. And I think this is really good that with the NIST Smart Grid Interoperability project and having so many different stakeholders coming together on some regular basis and talking, and also the work that's going on at DOE, this is very good because I would never thought a few years ago that the electric sector may be driving this next revolution in IP networking because of its unique business needs. And of course, with cloud computing and gaming and other industries, they are definitely going to benefit from this. So we really appreciate your coming today and talking about these subjects. What I want to do is get into the Q&A, and if we could just bring this down and see if folks on, okay. So for those of you who are on the webinar, feel free to put your questions to John in either the chat or the Q&A window. And what we will do here, because of the sound, we will ask people questions, and then we'll repeat the question for you so that you can hear it, because you will not hear the audio in the room. So let's start around the room if there are any questions for John. And then meanwhile, the webinar folks can enter their questions. And then we'll identify the person, and then we'll repeat the question.
Can you mention about how you would put the signature or the new key within the TCP? You mentioned about the first packet identifying itself or has that key to establish the session. Is that part of the existing protocol today, or is that a change that needs to be implemented?
So you might want to repeat the question.
So let me repeat the question. The question was, how do we actually insert identity into the beginning of a TCP packet, the first one, which is the TCP Syn, and does there require any change to the protocol standards? So what we do is we create a single-use token, which is essentially a cryptographic hash of keying material and various synchronous and asynchronous clocks. We generate this hash, and then we insert it into the sequence and ACK fields of a TCP session. On the first packet, the sequence field is an initial sequence number. That initial sequence number to a protocol stack as the initial sequence is essentially a random number. We substitute our random number, the value from our output from the hash function, for their random number from the original random number, and then we save off that original random number. That is how we insert it. We don't actually consume any bandwidth, and we communicate that information. On return, the TCP segment is acknowledged through the ACK number, and the ACK number is basically a byte offset of starting from the initial sequence number of the amount of data that has been communicated. When that ACK comes back, it will be the acknowledgement of the token that we inserted, not the original sequence number as generated by the host protocol stack. So that needs to be back translated to retain the transparency and ensure the integrity of the TCP session. So that's how it actually works. This scheme of adjusting TCP sequence numbers and ACK numbers is not new to BlackRidge. That scheme actually has been used most commonly by internet load balancers that operate at layer 7 to splice TCP sessions together. I don't know that it specifically requires any changes to the standard, but I mean, some people may argue around the edges on that, but our goal is to ensure that this is as compatible with all the legacy gear out there. So we're not really going down the path of changing the standard, because if you required a standards change, that would really invalidate most of the legacy gear, and we really focus a lot on the legacy stuff as well.
Okay. Other questions in the room?
Yeah, how does this defend against a replay attack? What if you replay a SYN?
The question was, how does this defend against a replay attack, and what if you replay a SYN? The tokens that we use in the header that we insert are protected against replay attacks in two different ways. First off, as soon as they are received by our TAC gateway, which is a policy enforcement device, it is immediately invalidated. Second, if it does not actually if it's intercepted and blocked and, say, saved away, the token itself will expire within a few seconds. So we ensure that if you try to use it immediately, an immediate replay attack, it doesn't work. And if you try to save it and archive it and use it in the future, it also doesn't work.
And what's the response to a SYN that fails authentication?
The question is, what is the response to a SYN that fails authentication? What happens if you are unable to identify it? We classify it as anonymous traffic, and then you say, okay, and then we apply what is the policy for anonymous traffic. That can be block, redirect, or forward, depending on the policy. So in most cases, it's going to be block, where we simply discard the packet, or we could redirect it to a honeynet or some accounting system, so you know, or if you want to have, I have these services set up for anonymous traffic and another set of services set up for my known traffic. It actually allows you to split your traffic and give best effort to the anonymous traffic and some other higher quality of service to the identified traffic.
Other questions in the room? You may want to look at some of the...
let me...
Oh, another question here.
Another question. Cliff?
So this only works for TCP/IP, right?
Today, our products today work for the TCP protocol. We are working on other protocols. The next one that we're really focusing on is UDP, so datagram versus stream protocols.
And it should be transparent for anything encapsulated with TCP?
Anything that if you're running encapsulation with TCP, it will work. We're not, so there are protocols that do not, basically there's reasons why they're not running over TCP, but any application, regardless of what it is, that's using TCP successfully today can use this.
And then, just to confirm, so layer 2 is still visible, right?
Layer 2 is visible, but layer 2 is basically your local access. I mean, the way we look at it is there are authentication and identity technologies that work at layer 2. The one people are most familiar with is 802.1x. The problem with 802.1x is it doesn't span router boundaries, and it's not end-to-end. So it works great within a LAN, but I really can't use it across a wide area unless I've just distributed. I'm running a layer 2 network.
And the algorithms you use to do your tokenization of the authentication, that's not public, right?
Sure it is.
I can't spook it. Like,
sure.
If I'm sniffing layer 2 traffic and I see something and I don't want to generate my own,
so the
man in the middle?
Sure. So the question is what is the token algorithm, and can I spoof it? We're not in the cryptographic hash algorithm business, so we are using HMAC SHA-256, which is one of the NIST certified algorithms certified for FIPS 140. The whole goal or the approach we take to designing this stuff is you can know everything about our system as long as you don't have the keys that are associated. This does require keying, and we can talk a little bit about that. But if you don't have the keys, even if you know the algorithm, even if you have the source code, you shouldn't be able to break it. And the other thing is the implementation of our hash algorithms. We've gone off and licensed the RSA BSafe library, so even the implementation of the hashing algorithm. And we're using that. We're using the CNG libraries from Microsoft, which are another set of certified libraries, and we're working through additional ways to achieve all of this that are fully interoperable.
John, I got a question in terms of deployment and management side. So when you set this behind, say, a particular portion of your gateway, is there a limitation on the amount of policy you can apply? So like you have an OU or an ACL, right? And depending on how you use your policy language, what that's called, is there a limitation on how many policies you can put behind one of your current boxes?
The question is there a limitation to the number of policies you can apply and behind stuff? So yes, there is a limitation. I don't know what it is. I'm thinking it's something like, and this is off the top of my head, I think it's like 1,000 rules or something. And those are not necessarily based on individual identities. They can be based on groups and things of that sort, but I don't have that exact answer.
So we'll take the questions that are now in the text while the people in the room formulate more sophisticated questions.
Okay, the first question I have from people online is the cybersecurity community ready for IPv6? I'm not sure I can answer that question. I would say our stuff, we're dual stack v4, v6 because we primarily operate at the TCP layer, and we make sure that we can operate in both. But I think it's been shown that you have more mature products in the IPv4 space, and some of the attacks you're seeing are because of the less mature v6 products. So yeah, it's getting there. I don't know what else to say about that one. Next one, Dale Gutierrez asks, President Obama's recent speech on the Lieberman Senate cybersecurity bill was met with some concern by some of the cybersecurity sector. What is your take on all this? I think industries more outside of the cybersecurity space are afraid of increased regulation and the burdens of both accounting and infrastructure that'll be placed on them. I think that's the real fear of the legislation. It's not a discounting the risk. It's the fear of overregulation. That's John's viewpoint. Okay, from Dale. Do you think multi-tiered authentication protocols should be reinforced rather than decreased for convenience? I'm not quite sure what you mean here. Do you mean multi-factor authentication? Or, well, if we're talking about multi-factor authentication, that's very useful. I'm not quite sure how to interpret this. Yes, multi-factor two-step. There's two parts to it. I want to make it secure while decreasing user interaction, which sound like I want to go into opposing directions at the same time. What I mean by that is if we can think single sign-on systems. While the initial portion of a single sign-on system may require two-factor or multi-factor authentication, everything else after that is hidden from the user. I'm still getting strong authentication. I'm still getting SAML assertions. Things of that sort are working so that the user doesn't have to remember, 20 different passwords that are not the same, that are 12 characters, that are, all of these requirements that are extremely hard. And having them type in a token every single time becomes extremely difficult. How can we take some of those things, simplify it, and just make it so the user doesn't see it? There will be some form of user authentication. If I've got a smart card, I got to type in my PIN. I may have to have some sort of biometrics. There may be something else with that. But then all of that, every other authentication that happens at the network layer, and then we can make SAML assertions up from the network layer, will allow basically cryptographic tokens doing this authentication, and the user doesn't interact. The idea is, how can you, the biggest problem with security is the users. How do we make it easy on the user so the user can actually use it, doesn't call the help desk, and doesn't create additional problems?
Question?
If you're ready.
Yes.
Sure.
Rob Ford. Thank you for this talk. One of my passions and interests is what you call the Internet of Things, where you don't have a help desk. You don't have people. And you may have alluded to this earlier in the talk before I got here. I'm sorry to be late. But what strikes, this isn't so much a question as a comment, but I'd love to get your take on it. What it strikes me about your technology and solution is that it really does scale to things beyond people. It's basically, the side effect of what you're doing is making it easy so people don't have to worry about all the things they have to do. But that's actually necessary if it's things and not people, right?
Yes. The biggest challenge, so to reiterate so everybody else can hear on the phone is if we take this and extrapolate it to the Internet of Things where there is no user and there is no user and there is no help desk, how do you make it all work? And what I would say our biggest challenge over the last several years has been working out scalability issues. And to me, the Internet of Things is all about scalability. There have been some reports that predict by 2020 there will be 50 billion things out there in the Internet of Things, and I've seen even larger numbers. So there was a report from Philips last year or something like that. Anyway, so some very interesting reports about the scalability. There's only 8 billion people out there, and there's something like 6 billion people that are on the Internet today if you include cell phone usage and smartphone usage. So it's really tremendous, but those are all the people. The Internet of Things is all sorts of autonomous things, and they're going to become smaller and smaller and more numerous and more numerous. And how do you track them all? And basically building systems that are scalable from an identity perspective, address independent, and topology independent. If you get down to the address and topology independent, that means they need to be self-learning, self-healing. There's all of these other things, and it really is a fascinating area just to go play around in and sort of work out. I believe your comment is, you're right, it's dead on applicable. It's going to take work to get there, but I think it's all achievable, and there's a lot of stuff we're trying to get there. It's just engineering. It just takes some time.
Just engineering.
Yeah.
So bringing the focus back to the energy sector, and when I say energy, I'm actually also including water and gas and electric. So all three of them involve SCADA. And the challenge with SCADA today is that with the deregulation that's going on in all of these sectors, you have multiple entities. And the multiple entities need to work together to make it work for the customer to get the service. The challenge is they have different budgets, IT budgets. They have different, what I would say, sizes of pockets in which they can sink their hands into to make investments. And the problem with cybersecurity is that if you really do a very good job in cybersecurity, you're invisible. So the problem with that is that when it comes each year to justify the investment in cyber, they say, well, nothing happened, so what are you doing? And you're like, well, I was really doing a good job, and that's why nothing happened. So it's very difficult to make the case when you're really doing a good job. It takes an incident of some kind, you know, like the Stuxnet or Flame or something, and then everyone wakes up and they want to suddenly throw lots of money and trying to get responses quickly. So one of the things that comes out of this paradigm shift of having so many parties now trying to deal with shrinking IT budgets is that the more you can automate systems, the more you can build security into mechanisms. Like today, we're talking about appliances from BlackRidge. You know, you can see them there. But eventually, I could see them getting miniaturized to the point where they'll actually become embedded. And after a while, it'll be maybe some firmware in a larger device. And it will, you know, enforce these policies, and we won't even know about it.
Did you see our roadmap?
No, I haven't seen the roadmap.
You're doing a great job of describing it, though. I mean, yeah,
but that's basically, you know, it's like vapor just slowly disappearing. And we saw that in the laptop industry, for instance. You remember the cards we used to stick into the sides of laptops? And then after a while, it's just kind of built into the system. Today, we have the standard interfaces. The key thing is that the way the TCP/IP protocol is today, and John went through the concept of layers, saying all of those layers are necessary. You need that VPN, you need the SSL, you need all of that. But it's necessary but not sufficient. And the reason why it's not sufficient is that all these new threat vectors that are coming as a result of multiple parties coming together. So when we look at the use cases in the electric sector or gas or water, you begin to see that as a result of these new applications that customers want, they want to see how much they're using, which means that there'll be some kind of connection to the service provider. There are multiple parties that are delivering. Some have got the meter. Some are measuring the energy use and then reporting. Some are providing the NAND. Some are providing back-end billing. All of these will have a peering relationship. So it's almost like Visa or MasterCard with the merchant banks. You know, it's like a peering. It's not a master-slave relationship the way you would if you go to Yahoo or a Google and you're just a customer on their website. So with this kind of a paradigm shift, start thinking about all the new threat vectors that are formed, because there is that implicit trust, but then there are people who will abuse the trust. There are industrial espionage rings that are hiring people with 2 W-2 forms, one for a legitimate business and the other one their own business. And they are in the business of taking data out, just siphoning data and using it at a time of their convenience. So having additional security controls that will de-incentivize these individuals from causing mischief is definitely a good thing. Now, the question I have for you is, even though it's based on an open standard, the TCP/IP standard, which has RFCs from IETF, I believe there are a couple hundred or so RFCs that are relevant to this space, how do you ensure a level playing field in the industry for the capability you're creating? I mean, I know you want to promote this and grow your business, but how do you create that balance?
Off the top of my head, I haven't actually thought of that before, so I'm not sure I really can give you a good answer. It's just not something we'd have to go think about that.
John, since you're the other John in this company.
Yeah, I mean, we're a 30-second background. I mean, we've been selling into the DoD for a couple of years now, and we just announced ourselves commercially in April this year. So we're still sort of formulating our growth as a company and how we approach these things. So at this point, the focus, or up to this point, the focus has been how do we grow ourselves, and I think we do need to address your question, but we need to look at that further.
Then I have a question for the utilities that are in the room, and we won't identify you. Just I'll ask the question, and then I can then report the answer without naming names. But the question that I have for the utilities that are in the room is, do you see the challenge that John is showing on TCP/IP networks? Do you see that in the work that you're doing, and do you feel that this enhanced capability will reduce some of those threat vectors in your environment that you see today?
Yeah, actually, and I was going to speak out your question or comment, and maybe either one of you could answer. You know, it is important to have, you know, a value proposition, which Erfan definitely mentioned, and also, you know, what challenges we see now that your solutions provide. And the biggest question I have, you know, taking it up to 50,000 feet, you must have a lot of comparisons with NAT, like network access control and all that. So, I mean, I think if you could maybe just illustrate your value proposition compared to, like, well, at least compared to NAT, you know, I could see how, you know, future projects would be valuable to have this solution instead. So maybe just talk a little bit about that.
Can you summarize the point and then answer it?
The question was, I guess the best way to summarize it is, this sounds a lot like a NAC solution. How are you the same or different, or contrast this to a NAC solution? Is that? Yeah. So I would say there's two fundamental ways that we differ from a NAC solution. So first off, for background, NAC is network access control, and it's really determining the posture of the device you wish to connect it to the network and making it pass certain thresholds before you allow it onto the network. Most commonly, NAC devices are coupled with a VPN so that I make sure that I'm running the the correct patch level, I've got my virus definitions up to date, all of those sort of things, and then I go into a VPN. Most NAC does not communicate identity. So NAC is very good at saying, what is the state of the device I'm allowing this network connection to? And likewise with most VPNs, it's a one-to-one connection. When I'm connected to a VPN to this network, that's probably the only VPN connection I'm allowed. So a NAC is policy before I allow VPN connection. Once you're inside, you're still back to implicit trust. That implicit trust is heightened because you've added more security here, but this is really what is the state of your endpoint. With identity-aware networking, there's two things you can do. The first is, and I really did not touch on this in the presentation, is we view this as it's not one administrative domain, it's n administrative domains. Because I'm doing this on a per-session basis, the example I normally use, I know it's outside of the power industry, is I have an account at two different banks, say B of A and Wells Fargo. If they're using both of these, if they're both using this mechanism, I need to make sure that I can communicate to both of my banks, authenticate with the right set of identities, and have each one being completely independently administrated at the same time. If you think of the cloud environment where, I can be doing everything from consumer Facebook to storing documents on Google Docs to something over here, all of these are happening at the same time. I don't establish a session necessarily and tear it down. I'm going back and forth between all these at the same time. So the multiple administrative domains, and I also have the ability to do explicit identity with that, explicit trust. As we go forward, I don't want to expose too much here, you will probably be seeing from us things that previously have been features of NAC solutions, like what version of software are you running? Are you at the correct patch levels? Things of that sort. So there's, I would say, more along the lines of application identity and how do you apply identity to that, when that becomes especially important in the bring your own device environments.
Okay. One exercise for someone in the room. Oh, yeah, there's a new. So, let me formulate the question for someone in the room. There are a set of failure scenarios that were developed in the NESCOR project, and someone in the room was quite active in the formulation of those failure scenarios. I think that what would be helpful is maybe take some of those failure scenarios and see what this enhancement could have done in terms of a different outcome in those failure scenarios, especially those that involve nefarious, not system errors, of course, but just people that did things. So the use case and the failure scenario that resulted from it, if we could cite a couple of them, what it could do is pique the interest of the IETF to pick this up and start putting some RFCs around this subject, so that it's no longer, because there are two aspects to this. There is the vendor aspect to it, and then there's the generic capability for the industry. And I think you are sitting on the fence of both.
We need to learn, and we need input from industry to make sure we're steering the protocols and the technology, and we actually deliver things that are useful, and it's not an 80% solution. The industry needs a solution for the industry. So it's a combination of input, feedback, and working with the industry to make sure the product delivers the industry requirements.
Right. So, I mean, putting it in more generic terms, BlackRidge has created an invention. We now need to see its potential to be an innovation. And for that, it needs a type of industry buy-in that really genuinely enhances business applications. So if there are use cases, especially like Southern California Edison and EPRI and NIST, we have this interoperability knowledge base now with lots of use cases. There are those that have cybersecurity significance. And there's architectural definition in some of those use cases that if we analyze and see if this could have made a difference, that could create a very good momentum, initial momentum to get the industry to rally around it, as opposed to, you know, just a company saying, you really need this, this is the best thing since apple pie. Question?
I have a semi-facetious suggestion based on your comment about different budgets or different sizes and you need to justify it.
Yes.
Make the default not be to drop packets, but to divert it to a honeypot. And at the end of every month, just take to the accounting department, here's how often the honeypot got hit. This is what we're doing. There's my semi-facetious.
Yes.
That would actually provide some really interesting information, too. I mean, just
So
in terms of forensics.
let's repeat the thing for the webinar folks.
The proposal being made in a semi-facetious way is, what if you take all of the unauthenticated or unauthorized traffic and direct it to a honeypot, and at the end of every month present accounting with the results? My comment to that is one, I think it's an excellent idea, but the other thing is it's also a trove of a huge amount of information about where things are coming from, what sort of attacks. I mean, it's basically things that we get to learn from. And a lot of this, to me, it's not just who's authenticated, who's not authenticated, but sort of some of the second-order effects you can get from information beyond that, which is so much better than the information we have today. Today, most of our information about attacks are really based on heuristic thresholds of traffic and things of this sort. There's a lot of heuristics around it, which is why the IDS and IPS industry hasn't done as well as it could have, because it's all heuristic-based, and the attackers learn the same heuristics. You don't think attackers go buy the same gear and test it? So you know, this is why that industry has been difficult. So I think the information generated from this could produce some really, really interesting information.
Yeah. So along those lines, I'm asking the folks from FireEye to present in September, and they will describe their appliance, which helps in understanding how malware spreads, and it's very interesting to get the what I call near zero-day protection. I don't call it zero-day, but near zero-day protection. Well, there was a question from the text.
I've got one more question here from David. Would you discuss what the PUC or CEC can do to assist the public utilities in the area of cybersecurity or R&D or standards?
Yeah, so just to elaborate on this, Dave Chambers is from the California Energy Commission from the cybersecurity side of things.
I was going to ask you to handle this question.
Oh, you wanted me to handle it? Okay. Can you repeat the question? What can they do?
Would you discuss what the PUC or CEC can do to assist the public utilities in the area of cybersecurity or R&D or standards?
Oh, wonderful. And for the...
So that's a question for the utilities.
Yeah, that's a question for the utilities. I just want to give a teaser, and then I'll give you the opportunity.
Go ahead.
So as a third party, as a neutral third party in this, who occasionally talks to the utility commissions and talks to the utilities, I have to say that in the policy from both CEC and CPUC, there is a possibility of what I call reducing the contention in the docket process, okay? And the way you can reduce that contention is come together to create a common framework, like DOE created a roadmap for the energy sector. One can also create a roadmap keeping in mind those things that we have commonly agreed are good security controls to have. And over some kind of a roadmap over the next 5 to 10 years, lay that out so that when the utilities come with their applications for funding for certain new cybersecurity controls, that it's not reinventing the wheel. The Public Utility Commission analysts and the CEC analysts already know about it. They can speak with their commissioners and let them know that we've already come to an agreement that this is something that's good, and the funding should be put into those dockets appropriately. Is that fair?
Oh, yeah, it sounds perfectly reasonable.
Okay. So since the reason why I'm saying this is because they're in the same cybersecurity working groups of NIST. They are sitting in the DOE NESCOR project. They are sitting in NERC SIP working groups. So the and I don't like using the term, but in cybersecurity it kind of sounds weird. But the usual suspects are all there, from the major IOUs and the utility commissions, and I know most of them by name and face now. So the issue is that they have two identities. There's one where they're in national efforts trying to come up with requirements and all that. Then they go back into their states and they go back into their respective positions where one is trying to convince the other. And I think that this could be avoided by having a more proactive approach that emanates from the DUGs and the CSWGs, but create a finding that can apply nationally so that you don't have to have the state, but the cybersecurity threat, okay, granted there may be some geographical variations, but in today's world with TCP/IP network where people can launch attacks from anywhere, I think that there's enough commonality that could be then replicated in the different states so that we don't have this challenge.
For the most part. But I think there's also different regulatory challenges.
Yeah.
And I also think that we do ourselves a disservice by staying in the TCP/IP realm.
Yeah.
I think that there are protocols out there that are not TCP/IP that have not been vetted the same as TCP/IP, that have, and at the same time, should be learning what we're learning, as we go on the TCP/IP side of things. I mean,
yeah.
Protocol first started, it was a free-for-all.
Yeah.
And there was a reason that banks didn't want to jump right in and do that, because it was just another way to get robbed. And I think that there are other protocols that could benefit from the lessons learned rather than having to go through the pain. I think to kind of get back to the original question of how to help or facilitate is, I think one of the challenges is being able to communicate. I mean, as you know, with vulnerabilities, trying to communicate security-type information to someone puts the security-type information at risk, especially when you're talking about any kind of regulated entity. So without the ability to communicate vulnerabilities upwards in the chain, there is a chance that regulatory bodies will make decisions that could actually be impacting the security posture because they don't have the full information in front of them. And so I think one of the ways that there could be help is to make it so that there are better ways to communicate that information so that it doesn't all of a sudden turn out that it shows up on someone's log.
Right.
Not that it does, but there's always the problem of, as you communicate things upward, that it may not be kept as secure as it should be.
So John and I are going to share in summarizing the point that was made in the room. I think that there was a very strong and good point made that the cybersecurity threats are not just limited to TCP/IP networks, and that other protocols, like Modbus and BACnet and others need to be also looked at. And also, a lot of the AMI solutions out there don't have IP in their guts. They may have it on the boundary. So there are many non-IP-based protocols out there in the energy sector, especially some of the legacy systems, and that it would be good to have a more comprehensive view. So on that point, I would like to say that the use case approach is actually agnostic to that protocol. So as long as you are testing the different business applications, then whatever infrastructure is underneath it needs to be vetted, whatever the protocol may be in that space. But it's important to look at all those different use cases. And then, unfortunately, use cases take you just in the direction of interfaces. Whereas in cybersecurity, you have to have a hybrid approach. You have to look at interfaces, so like what the CSWG, the NIST 7628 document does, but then also look at it in a systemic manner, because there are threats to the system itself that could affect the CPU or other resources. So it's good to use the business, the use case approach to look at things, and whatever the protocols are underneath it need to be vetted. And the second part, I'll let John.
Well, I was going to just sort of follow up on what you were saying.
Yeah.
And first off, the protocols supported today in this approach can be thought of an implementation, but the concept of always ensuring that you present identity when you're presenting a connection request is something that probably should be enshrined more broadly. The other thing, anecdotally, is this concept isn't new. This isn't, we didn't invent the concept. We might have been the first to apply it to TCP, but anybody who was around when the ISO protocol stack was still competing with TCP in the late 1980s and 1990, there's a protocol there called TP4, Transport Protocol 4, which is analogous to TCP, and on the connect packet, which is equivalent to the Syn packet, in TP4, they allowed up to 16 bytes of user data that you could use for authentication. So this is not new.
Yeah. One point I'd like to add, Dave, if you're still on the webinar, as far as what CEC and CPUC can do. CEC did a great job by putting together this roadmap project which EPRI ran and had all the three major utilities, IOUs, and SMUD also was involved in that, in terms of creating a roadmap for smart grid for the next 10 years. And it really encouraged the utilities to come together, and initially it was tough, and eventually once the perspectives gelled together, we were very productive as a team. I know in cybersecurity, it's a challenge. And the reason is if you tell too much, then you're exposing yourself. But there is a happy medium, I think, that on controls, you can come to an agreement. But how you actually implement, which technologies do you put to implement it, can vary from one utility to another. And that kind of happy medium brings you into the same zip code, but doesn't tell you which street and which house you're in. And I think that if the CPUC and CEC approve budgets that allow for that collaborative research to occur, I think will be a very valuable contribution. Other questions? Anything from text?
I have a point I'd like to add.
Yes.
Because there's a lot of technical conversation going on right now, and I do a lot of work with the guys at SpearPoint. Billy Rios and Terry McCorkle, 90% of the attribution for all the vaults for ICS are 2011 this year. The problem that's not the kind of the elephant in the room, so to speak, is the ICS vendors are not responsible for the code they're putting out. So Microsoft has a patch cycle. They have Super Tuesday. They came up with this whole process of patching for free. At the moment, the way that the ICS software vendors are providing their code is really bad. Number one, using IE6 as a standard for most of the HMI. They have a TCP/IP spec that's different than most software vendors, which is news to most folks that are involved in InfoSec. And on top of that, utility providers have not really banded together to say, look, we need you guys to vet your code before you sell it to us. Or we'd like to see a patch cycle implemented. Of course, on the PLC, the DVC side, you can't implement patches to fix the firmware. It's a little unlikely because there's no redundancy. There's also, they're in real time and they're actually controlling critical infrastructure. So, in short, the utility providers and entities need to actually tell the software vendors, we can't have you guys putting out code that's got no verification check process. I mean, some of the stuff that you're seeing is fantastic. That's control being enabled, no password, hard-coded password. I mean, password 86. I mean, it's pretty bad. So it's great to go and talk about policy, which is really at the end game that's going to result in change. But, I mean, the software vendors are not responsible, and they're passing the costs off to the guys that buy this.
Do you want to summarize that?
So summarizing the statements, and I guess there's a comment in there, is a lot of the software vendors for the embedded systems, the patch cycles, well, first off, is the software is not well authenticated. We don't know how, and requiring patches and sort of the baselines for it, it sounds to me like that there's just some fundamental more testing, more verification that needs to be done, and basically more rigor put into the software process overall, and that the actual software vendors are not being held as accountable as they should be. I mean, if I'm paraphrasing, but I hope I'm getting the spirit of it right.
iTunes has more accountability to their customer base than Siemens does to their customer base.
Yeah. The statement was iTunes has more accountability, even in light of what happened last week, to their customers than Siemens does.
Without picking on Siemens.
Yeah, ICS software vendors, Rockwell, GE, they're all in the same boat.
Okay. So this brings us, we're...
Just
Yes.
To what you were saying about failure scenarios and so forth. And I did just wrap it up with a few comments. You can definitely probably address failure scenarios where you spoke about earlier how, through acquisition or divestiture, you're taking a network and then all of a sudden, you're making changes to the network and then all of a sudden your data network is exposed.
Yes.
So that's definitely one of the failure scenarios that has been known out there. And the second one that you might want to emphasize is, your response to deauthorization. So, you have people that are authorized out there, but all of a sudden, if your monitoring systems say they shouldn't be authorized any further, it behooves you to speak how quickly you can take away that authorization.
So the question was really about authorization systems, and if a operator, user, what have you, I'm going to call them an identified individual, authorization is revoked, how quickly can that propagate in the system? So the simple answer is very quickly, but it really depends on two things. Is it the identity that's going away? There's two ways that can happen. The authorization can be removed, or the identity can be invalidated. And those are two different paths through the systems. The identity system, we are actually not, so this is really designed to use external identity systems. So in some ways, that's a propagation of how long it takes to propagate through the identity system. We will revalidate the identities periodically. That can be adjusted, and which basically is a querying the CA to say, is this guy still valid, or is it in the CRL? Otherwise, if it's just a policy, the policy on a valid identity can be modified in much more real time. So there's two slightly different answers depending on which path is taken.
Yeah, I would say that is a policy change.
Yeah, the policy change can be made pretty quick, and in fact, we can even track down active sessions and terminate them if necessary.
Okay, so for the folks on the webinar, we are going to continue our discussion here in the room, but our webinar is going to end in the next couple of minutes. So I have some logistical notes to make and then some final comments, and then we will see you in, as they say, in a theater near you. But the point I wanted to make is first, on August 21st, which is a week from tomorrow, we're going to have a seminar at IBM in Foster City on demand response and dynamic pricing. And Dr. Ahmed Faruqi, who is with the Brattle Group, is going to talk about some real results from pilot projects in utilities about showing how effective these demand response programs have been and what are some of the challenges with dynamic pricing. And then in September, we are going to have a seminar from a company called Albedo, and Albedo is going to talk about the security that's needed in business process. And so you may have seen companies coming up in this area where they're saying it's important to secure communications and applications, but the business part needs to be also looked at, and there are several companies in that space. And then I'm asking FireEye, and this is literally an invitation over the web. I mean, we have exchanged emails, but I'm literally putting them on the spot. I'd like them to come and talk because there have been some large federal organizations that have been protected from this Stuxnet and other viruses as a result of using that FireEye technology to give them that near zero-day protection. I think that bringing the business part, the comms part, and this malware spread part all together, we're really trying to control this beast, but it's multifaceted. And so being a plasma physicist, I will tell you that a very good analogy for this is trying to hold Jell-O in a bag made of rubber bands. And that's what this field is a lot like. When you're trying to push one side, it seems to spew out of another side. So just keep that model in mind. Couple of notes to end this session. One is that John's presentation underscores the need for education in this field. And when I say education, I mean that with the vast spectrum of utilities in this business, from the smallest co-ops to the largest IOUs, I have seen very different skill sets. And it's not necessarily that just the big ones have all the smart cybersecurity people and the small ones don't. It's not like that. But there isn't the universal level of what I would say professional experience. And the challenge is that in a highly inter-networked energy sector, and then tomorrow it'll be connected with gas and water, there is a need for education so that there is a minimum level of understanding about the major security threats, what kind of controls you need to have in place. And unfortunately, programs like CISSP and taking a course in college doesn't cut it. There has to be a more applied education. And I'm challenging the folks in the room as well as in the webinar is to start thinking of putting modules together, academic modules, so that in addition to the collaborative research work that's going on in NIST and DOE and NERC, that there's an educational aspect to bring them up to speed. Some of the material may be reviewed, but the very applied way of looking, like the way we're talking about SCADA systems and cloud computing, we need to have that very applied view put with cybersecurity so that there is a culture and there's an awareness in organizations. And then these security people trained in these applied ways can work in their respective organizations to create more awareness and reduce the amount of social engineering that is occurring in organizations. So that's one point. The other point is compliance, and this brings us to the National Technical Systems that's hosting us today. That the other side of education is compliance. So when Michael was talking about software vendors and not meeting certain standards, I have to say that we don't have enough of an understanding on what constitutes compliance. We have people who say, oh, I am FIPS 140. I am, approved by NIST. Well, what does that mean, approved by NIST? You took a bunch of non-functional requirements and you are suddenly compliant? I mean, what exactly are you up to? So there are these statements that are made, that we are in the universe. We are now in the Milky Way. And so what we need to do is have a little more definition on what constitutes compliance. And there are levels of compliance. We have found even with protocols that two people will say we are compliant to the same protocol, but they didn't go down to the most granular level of detail, and therefore there was variation and there was no interoperability between their products. So these are things that, and this is why I'm trying to do this through the Smart Grid Educational Series, is that I'm trying to promote a culture of uniformity of minimum standards, just like we do in education, just like we do in driving, just like we do in bumpers on cars. There has to be some standard. And I think some of the utilities that have the larger budgets and the more experienced people could act as mentors for others in this industry. And I would say that gas and water need all the help that they can get. They're suddenly becoming networked. And so the electricity sector and the gas and water can really work together very well. And if you look at the roadmap from DOE, you begin to see that connection. So I'm kind of challenging the folks in the room without naming them, of course, to start thinking in building forums like educational forums and requirements for compliance so that companies like National Technical Systems and others can have a more constructive engagement and have a larger market. Because right now what's happening is that the very proactive folks in some utilities are engaging, while others are waiting on the fence for something to happen and then they will join. And I think that would be tragic. I think this is the time for we have the window of opportunity to make the correct investments so that the vendors who are in this space know exactly what to put in their roadmap, and it should be part of their budget. So with those thoughts, And I will continue giving these golden nuggets in the future in my forums. And I really, really appreciate all of you who are on the web. You have stayed. There's still 20 of you there from a peak of about 35. So I really appreciate your time. I appreciate the time of the folks here in the room. At this point, what I will do is, was there another question?
Just some comments.
Oh, they were accolades for John, that the presentation was very good with V capitalized. So that was very good. Okay, I'm going to end this recording now, and we are going to continue our session here, but the webinar will come to an end. So thank you all for attending via the webinar, and good afternoon.